My name is Anthony Nathaniel, and I welcome you back to Global Education Zone. In your previous knowledge, you have known of angles and trigonometry, right? Now, in this video, we're stepping trigonometry up a level higher for the secondary school, and in this video, we're talking about angles, not just angles in the positive axis, as you might have known, but angles from 0 to 360 degrees. Now, let's talk about that here. Now we have general angles, right? Your general angle, the ones you know, are in the first quadrant. But in trigonometry, in general, we have angles in the first, in the second, in the third, and the fourth quadrant. Now, in the first quadrant, all your angles are positive, right? And that is the normal one you know. And it is in the first quadrant that we have the definition and we have the illustration of our trigonometric ratios. Now, we have the Cartesian axis. Before we talk about this quadrant, let's introduce the axis. Now, axes, these are planes that intersect at right angles to each other. So, for example, this Cartesian axis, we have the positive Cartesian axis and we have the negative Cartesian axis. So, this horizontal axis is called the x-axis, and this x-axis, the positive x-axis goes in the right direction. This would be plus y plus x. Then the negative x-axis goes in the opposite direction, which is to the left. That's minus x. Then the positive y-axis goes upward, that is plus y. Then the negative y-axis goes downward, that is minus y. Now these are the Cartesians, and it is in this Cartesian plane that we have our trigonometry, because trigonometry and geometry, they are very linked, they are very interlinked to each other. So trigonometry is just like the brother or rather the sibling of geometry. Now let's talk about the four quadrants. Now there are four quadrants in trigonometry, and the first quadrant, this is the first quadrant. This is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the last quadrant. That is the fourth quadrant. So we have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now the first quadrant, it is a quadrant in which we have the positive axis in the first quadrant, but in the remaining of the quadrant we have the negative axis bordering it. For example, in this first quadrant, you can see that the borders of the first quadrant are plus y and plus x, but in the fourth quadrant we have plus y and minus x. It's bordering both negative and positive. For the third, we have minus y and minus y. We have both negative, and then for the second we have plus y and minus x. So it is only in the first quadrant. That is why it's only in the first quadrant that all your angles will be positive. So, but in the rest of the quadrants, your angles will be either positive or negative. Now let's talk about angles. Okay, yeah. Let's talk about the angles of each of these first quadrants. Now you always have a line, right? Now let's talk about a line. And if we have a line like this, we'll have the angle that this line makes with the horizontal, and this angle is the angle we use to calculate the ratios of these angles in the quadrant. For example, in this first quadrant we have the line in this first quadrant. Then we use the angle, which is the angle between the line and the x-axis. So let's call it theta. So this theta, we have the angle between the line and the x-axis as theta. So this theta will be used to calculate the trigonometric ratios. So if you've not forgotten, in our video on trigonometry, I touched upon your sine theta, your cos theta, and your tan theta. Now your sine theta is opposite of hypotenuse, and if we want to represent it as here, we have the line. So if we have this we have a let's have a dotted line here. So the sine of this angle will be the opposite divided by the hypotenuse. So this will be opposite to hypotenuse, right? So the opposite here is in the direction of y. So that means the sine theta will be what? That will be, the opposite is y, because it's parallel to y over, because it will have a magnitude of y. So then we have the hypotenuse, we have magnitude of, let's call it r, where r will be the length of the line. So let's call it r, theta over r. Then we have the cosine. The cosine will be, the cos theta will be equals to adjacent of hypotenuse. So this adjacent will be the x because it is below, that's x-axis. So adjacent is x over, then the hypotenuse is still the length of the line, x over r. Then we have tan theta will be equals to, tan theta is opposite over adjacent. So tan theta is what? Y over x. That's tan theta is y over x. Now that is for the fourth quadrant. So you can see that in each of these three angles, your sine, your cos, and your tan are all positive in the first quadrant. So let's move on to the second quadrant. So this second quadrant, let's cut out a part of this quadrant. Let's cut the second quadrant out and let's draw it here. So this is how the second quadrant looks. It has a negative x minus x and it has a positive y plus y. But in this time around, the line is now in the second quadrant. So we'll have the line facing here. But let's still trace the first quadrant. So if we want to measure the angle from the positive x-axis, because when time you are deriving the value of all these quadrants, you have to measure the angle from the positive x-axis. So let's measure the angle from this positive, and let's call this theta 2. Let's call this theta 1. That's the angle in the first quadrant. Let's call theta 2 the angle in the second quadrant. Now this angle in the second quadrant, it is what we are going to be using to calculate the trigonometric ratios. So for this one, the sine angle will be equal to the sine angle. We can still make use of this. Let's call this one another theta. So the sine angle will be what? Let's call this theta 2 complement. Now this theta 2 complement, that will be the sine will be opposite of hypotenuse. That will be y. Sine will be y over y over r. So sine is positive. Then cos will be what? Cos will be minus x over r, and then tan will be tan theta will be y over x, y over minus x. So y over minus x is still the same thing as minus x over y. Now you can see from these diagrams that it is only your sine ratio that is positive in your second quadrant. So, but in your first quadrant, both your sine, your cos, and your tangent are positive. In your second quadrant, only your sine is positive. In your third quadrant, only your tan is positive. In your last quadrant, only your cosine is positive. So that is how each of them shows the 4 quadrants of the circle. Now I won't derive the third and the fourth, but I will give you the general formula for each of the angles. So for your first quadrant, you have sine theta, cos theta, and tan theta. So let's express each of these in terms of the second, third, and last quadrant. For your second quadrant, you have your sine theta 2 is equals to sine, then open bracket 180 minus theta 1. So if your theta 1 is your angle in the first quadrant, and you want to calculate your trigonometric ratios in your second quadrant, you are going to make use of the subtraction of 180 from your angle in your first quadrant. So if your angle in your first quadrant is 180, that is the angle on the line. Angle on the line minus the angle in the first quadrant to give you the sine of the angle in the second quadrant. So in other words, sine theta 2 is equal to sine open bracket 180 minus theta 1. Then for your third quadrant, sine theta 3 is equal to sine 180 plus theta 1. So this is just a summary. Then and you can replace this with cos, you can replace this with tan. So we can, for the third one, you can just say cos theta 4 is equal to cos 360 minus theta 1. So this is just an example. So in general, your angles, the value of your angles in second quadrant relative to the first quadrant is equal to 180 minus that minus the angle in the first quadrant. Then the angle in the second quadrant, sorry, the angle in the third relative to the first is 180 plus that angle. Then in the fourth quadrant, it will be 360 minus that angle in the first. That is the angle in the first quadrant. So this is just relative ones. So if you still don't understand this concept, you can still check it up in your textbooks. So, but for this video, this is as far as we can go on this concept. So now let's move on to the drawing of these angles. So this last part of this video, let's talk about how do we express the sine, cosines, and tangents of each of these angles. So let's do something like this. Let's what we can do. Okay, yes. So now our question says express the sine, cosine, and tangent of a 60 degree, 120 degree, 240 degree, and 300 degree. So we are looking for the sine, cos, and tan of this angle. So we will just look for the sine, cos, and tan of these angles. So for the first one, we have so I'll give an example of the first and the third. So for the first, we have 60 degrees. Now let's draw our 4 quadrants. This is the first quadrant. This is the fourth quadrant. This is third quadrant. And this is second quadrant. So this first, second, third, and fourth quadrant. Now your 60 degrees in your first quadrant, right? So, and that means it's positive because all your angles, all your cosine ratios, all your trigonometric ratios are positive in your first quadrant. So there's a mnemonic for that. So you just put replace these ones by, since all are positive, just call this A. This one only sign is positive, let's write S. This one only tangent is positive, let's write T. This last quadrant, let's only cosine is positive, that will be C. So there's a mnemonic for this. This is ACTS, Acts. So if you are Christian, you would have probably read the book of Acts in the New Testament. So that's just a digression, but it's a useful one. Now let's move on. Let's talk about the angle. So if we are looking for the sine of this angle, that will be sine 60 degrees. That will be positive, and the sodic ratio, that will be root 3 over 2. Now let's have cos 60 degrees equals to, now the cos of this angle, the sodic ratio is 1 over 2. Then let's have tan T and tan 60 degrees. So also be positive because everything is positive. Tan 60 degrees will be root 3. That is for the first one. Let's move on to the third question. So the third one is 240. So what is the sine, cos, and tan of 240 degrees? So let's draw our. So this is our quadrant. We've drawn it again. So but in your 240 degrees, your 240 degree falls in your third quadrant because your first quadrant is from 0 to 90, has a limit of 0 to 90. Your second quadrant has a limit of 91 to 180. Your third quadrant has a limit of 181 to 270. Then your last one has 271 to 360. So anything that falls between 180 and 270 will be your third quadrant. So that means these are 240 degrees falls between 180 and 270 degrees. That will be in the third quadrant. So now in our third quadrant, you can see that only the tangent is positive. So let's do sine 240 equals to cos 240 equals, and tan 240 equals. So now let's look for without using your calculator, there's a method for this. So before I clean the board, I talk about in your third quadrant, your formula is your angle in your third quadrant, the trigonometric ratio of your angle in your third quadrant will be equals to 180 added to the trigonometric ratio in your first quadrant. So for 240, that means for sine 240 will be equals to sine 180 is a plus. Now that 180 plus your angle in your first quadrant plus theta. That means sine 240 is sine 180 plus theta. So if we equate both sides, that means 240 degree equals 180 plus theta. So that means theta will be what? 240 minus 180 degree. So that's theta will be what? 60 degree. So now, since our sine is negative, so our sine will be the negative of sine 60. That's minus root 3 over 2. Because this is the third quadrant. Then your cos is also negative. For your cos will be the negative of sine of 60 because your effective angle is 60 degrees. So cos will be the negative of cos 60. That's minus 1 over 2. Then your tan 240 will be the positive because only your tan is positive. So you know that the effective angle, that's the relative angle is 60 degrees. When you have a 240 degree, the relative angle in terms of the first quadrant will be 60 degrees. So the tan of 60 degrees is positive because in this angle is a third quadrant. So the tan in the third quadrant is positive. So tan 240 will be equal to positive of tan 60. That's 3. So this is a demonstration and illustration of those formulas I showed you earlier in this video. So thank you for staying up to this time in this video. Don't forget to like, share, and subscribe so that I can continue to post and update you on topics like this and contents like this. And thank you for watching. See you next episode.